So what did we learn yesterday? We talked about the basic concepts of probability. Yeah. So I'll just do a quick recap of what we learned yesterday. So probability is nothing but a more advanced way of saying a chance of something happening. That is what is probability. So let's see if I'm playing with a dice. I'm rolling a dice. Dice has 6 sides, written 1 to 6 on it. So when I'm rolling a dice, okay, it has 1, 2, 3, 4, 5, 6 printed on it. When I roll it, I can get a 1, I can get a 2, I can get up to 6. These are all possible numbers that can come. Can I get a 7 when I roll a dice? No. So, probability of 7 coming when I throw a dice is 0. So, this is the least probability that you can have. The smallest value for probability you can have. Anything that is not going to come, the probability of that is going to be 0. That's how you denote. So if you say something will not happen, let's say, can I get a yellow ball while picking a ball from a bag which has orange, red and maroon? Can I get a yellow ball? Answer is no. If you say that in probability terms, you will say the probability of getting a yellow ball from a bag of red, blue and maroon is 0. So that is always the least probability for anything. Clear? Now, let's say you have a bag full of, let's say, orange candies. All orange candies. Okay? What is the probability of getting an orange candy in your first pick? It's a bag full of orange candies only. Randomly you picked one. What is the probability of getting an orange candy? 100%. 100% or 1. Okay? So any probability, the smallest value you can have is 0 and the maximum value you can have is 1 or 100%. You can say that in percentage terms, you can say the lowest probability of anything is 0% and the maximum percentage is 100%. In absolute terms, you can say 0 or 1. Okay? Let's look at when you are tossing a coin. You can get a head or you can get a tail. What is the probability of getting a head? That is 1 by 2, half. Or you can say that 50%. Okay? So this is what we have learned so far. And the only additional thing that we have looked at is the maximum and minimum probability. Okay? Now, there is another thing that we have to learn. And did you guys get to see what all topics I had put in the chat? In Telegram message? No? Okay. So let me read it for you guys. So that way. See, we are going to learn experimental probability. We are going to learn what is theoretical probability. And we are going to learn intuitive sense of probability. That's what we briefly touched upon. And then we learn the difference between theoretical and experimental probability. And then probability of compound scenarios. Yeah, take a chair. Mitran is here. Alright. So, let me keep it open so that I don't miss any topic here, okay? Alright, so I was just doing a recap of what we have learned so far with respect to probability. So, you guys understood what do we mean by probability? It's nothing but a chance. Chance of something happening. Let's say if I'm throwing a coin, I can get a head or a tail. And both are equally probable, so 50% for getting one of them. Let's say if I'm talking about throwing a dice which has 1, 2, 3, 4, 5, 6. So what I was saying was, what is the probability of getting a 7 when I roll the dice?
1 in 6.
Hear me out. What is the probability of getting a 7?
0%.
0%. So 0% or 0 in absolute terms. It is called the least probability of anything. And if I have a dice which has only 1 written on all the sides, okay? This is a fake dice made in China. Okay, made anywhere. Okay, so it has only 1 printed on all the sides. Only 1. When I throw it, what is the possibility of getting a 1?
100%.
100%. So, or 1 in absolute terms. So this is the value that you will get for probability. All the value of your probability will be in this range. This is the minimum range for probability, this minimum value for probability, and this is the maximum value for probability. You will never have a probability more than 1. And you will never have a probability less than 0, meaning negative. Okay?
Okay.
So this is called intuitive probability. Okay, 0 and 1 is an intuitive probability. It gives you a reason or a way to think what is the minimum and maximum range that we are talking about. Okay, so this is called intuitive probability. Now let's look at the other forms of probability. Any questions before I move on? Okay. Now let's look at one more thing. So let's get rid of this fake dice. Talking about a dice which has 6 sides and 6 numbers into it. What is the possibility or probability of getting a number greater than or equal to 2?
That would be 5, 6.
Okay. Let's see. Srivatsa is saying something.
Oh, I didn't hear the question correctly.
I'm saying, when I'm throwing a dice, what is the probability of getting more than or equal to 2?
One out of 6.
I said more than or equal to 2.
Oh, 2. 4 out of 5 out of 6.
That's what you're saying, written also, right? Okay, yeah, it's 5 out of 6. Arna, do you think what Srivatsa is saying is correct?
Yeah.
Why? No, see, I'll ask question just to make sure that you get it right. Okay, everybody gets it right. I'll anyways explain it, but I'm just trying to understand. Okay, let me explain it for everybody. Okay, I know you guys know it, but what happens is when it comes to explaining it, we get stuck. Okay, that's natural. Okay, now let's look at this. When I'm throwing a dice, I can get 1, 2, 3, 4, 5, and 6. I can get one of these. Correct? What is the probability of getting 1? It is 1 by 6. What is the probability of getting 2? That is also 1 by 6. What is the probability of getting 3? That is also 1 by 6. What is the probability of getting 4? That is also 1 by 6. What is the probability of getting 5? That is also 1 by 6. What is the probability of getting 6? That is also 1 by 6. Yeah? Now, my question was, what is the probability of getting more than 2? More than equal to 2. So what I'm talking about is more than equal to 2. So this one valid. This one also I need more than equal to 2. 4 is also more than equal to 2. That is also I need. 5 is also more than equal to 2. I need that also. 6 is also more than 2. More than equal to 2. I need that also. So I need this 5. So basically all these 5 from 2 to 6, everything I have to count. That is how I have to add the probability of all the numbers. So basically I have to add 1 by 6 5 times. That is how it becomes 5 times 1 by 6. And the probability is 5 by 6. Does it make sense to everybody?
Yeah.
Yeah? See what's up? You're with me? Adnan, you're with me?
What?
Are you with me?
Yeah.
Did you understand what I was
I'm
saying?
writing down.
Yeah?
I'm just writing down.
Okay. Now, if I change the question, okay? If I say, what is the probability of getting a number greater than or equal to 4? What will that be?
Would be like
It would be like what? 3, 6.
Let me hear Adna, okay? Let me hear. Yes, Adna, go ahead. See, the technique I use, right? I make everybody participate. So that gives me confidence that, okay, whatever I'm teaching is reaching everybody. Okay? So let me see. Yeah, Adna, I'm just doing extension of what we talked just now. Same question. If I'm throwing a dice, what is the probability of getting a number more than or equal to 4? More than or equal to 4. So make sure that you listen to me carefully. So when I'm saying more than or equal to 4, do you guys know what are the numbers that I'm wanting to consider? Yeah? Mitran, you're with me? See what's up?
yeah.
Yeah.
6.
3 out of 6. So basically when I'm saying more than or equal to 4, I'm counting 4, 5 and 6. So that is 3 out of 6. That makes it 3 by 6. If I take out this equal to sign, if I say what is the probability of getting a number more than 4?
That would be 2.
2 by 6, because the equal to part I have taken out. I am not considering 4 now. I am only considering 5 and 6. That is 2 by 6. Okay? Yeah? Arnab, are you able to follow me?
Yeah.
You guys can see the board, right?
Yeah.
Oh, okay, yeah. So here, these are not difficult concepts. You just have to be extra careful while reading the questions, okay? If they take out the equal to sign or put the equal to sign, the answer could change. So that is where your attention will be needed. Otherwise, these are not very complex concepts. Okay. So now, let's look at another thing. That is called experimental probability. Okay. Now, let's think of a bag. A very big bag. Okay. Okay. Let's call it a candy box or the candy bag that you guys use for Halloween. Yeah. And it has 100 candies, 100 orange candies, 200 peach flavor candies,
Okay.
and 400 melon flavor candies. So this candy box that you took out during the Halloween, you collected this many candies. You have 100 orange candies, 200 peach flavor candies, and 400 melon flavor candies. Okay? So in total you have 700 candies. Okay? if you pick first, you pick candies one after another. You pick one, so okay, orange, put it back. Pick another one, you got melon, put it back. You picked up next one, that also came as melon, put it back. Fourth time you picked up something, you got a peach flavor, put it back. Likewise, you do the experiment. Okay, you picked 100 candies. Okay, you picked 100 one by one and you counted, wrote it down. Out of 100 attempts you made, you got, let's say, 30 peach flavor, 20 orange flavor, and 50 as melon flavor. Okay, this is what you got. And again, don't worry about the numbers, I'm just telling you guys the concept. Okay, that you have a bag, you know that, okay, I have 100 orange candies, 200 peach candies, and 400 melon candies. Okay, you picked 100 candies one after another. Okay, and this is what you found, that out of the 100 picks you had, you got 30 peach flavor, 20 orange flavor, and 50 melon flavor. Okay, whatever I have said so far, just process that information and we'll resume in a minute. Okay, I want you guys to think about what I said just now. Okay, now there are two things here. One is the theory, the concept that we know, and one is the actual value by doing it. Now let's go back to the concept. Okay, if I have 100 orange candies, 200 peach candies, and 400 melon candies, what is the probability of getting a peach candy? Orange candy. It is 100 by 700. That is 1 by 7. This is for orange. This is based on the concept. Yeah. What is the probability of getting a peach candy? It is 200 by 700. Yeah.
Yeah.
What is the probability for melon candy?
400 by 700.
Yeah. That is
4
by
7. And the other one is 2 7.
2 by 7. This is the probability that you know based on the concept. Yeah. Now, when you do this experiment, meaning somebody actually picked up candy one after another and found this. Look at this probability. Okay. What did you get here? For the peach, you got 30 by 100. Orange, you got 20 by 100. And melon, you got 50 by 100. So it is peach. Okay, let me write it down neatly here. So there are two values. Okay, one is the conceptual, one is experimental. Okay, based on the concept that you know, orange is 1 by 7, peach is 2 by 7, and melon is 4 by 7. Now look at the experiment part. What did you get? Peach, you got 30 by 100, that is 3 by 10. Orange, you got 20 out of 100. So orange is, oops, what did I do? Orange is 20 by 100, that is 2 by 10.
We can also be 1
by 5. Yeah? Peach we got as 30 by 100, that is 3 by 10. Melon we got 50 by 100, 1 by 2. So, by doing all that I did just now, what I am trying to show you guys is, there is one conceptual level probability concept that we know, and you can also do experiments and you can get the value. And this gives you a more accurate value when you do the experimental probability. Okay, so if you know that by concept this is my probability, but if somebody, let's say, does 1000 experiments, okay, That person says, okay, I'll pick up the candy 1,000 times. And this is the count I got. Then based on the value that you get, that is called your experimental probability. Based on that, you can relate that to the concept and say, hey, when I did the actual experiment with enough number of iterations, this is the value I got. So that is another form of probability which is called experimental probability.
Okay.
Let me see. Yeah. Yes, you also.
Nothing.
Nothing? No, so my question to you guys is, did I make enough sense so far?
Yeah.
Yeah.
So in summary, probability is a concept which tells you what is the likelihood of something happening. And that is what we have learned by looking at these numbers. This is called conceptual probability or based on understanding of things. But you can prove that by doing enough experiment. Let's say if you just pick the candies 5 times and then you try using the probability, that is probably not going to be accurate. But if you do it more and more number of times, you do it 100 times, 1,000 times, 5,000 times, then you will see that your experimental value gets closer to this. If you take smaller sample, do it only 2, 3, 4 times and then you try deriving a trend, that is when you will not be very accurate. But if you do it enough number of times, that is when you will see your experimental probability is actually closer to this one. Okay? This is called law of averages actually. If you do something enough number of times, the average that you will get will be more closer to the overall normalized form of it, normalized value for it.
Yes. Okay.
Okay. Any questions so far before we move on?
No.
Okay. Now, there's one more concept that we need to learn. Yeah, please. Go ahead. Yeah, Anna. Anna, you were saying something?
I was asking if I can go to the back.
You want to take a break?
No, I was asking if I can go to the back.
Yeah, sure. We can wait for 2 minutes, okay? That's okay. So we'll just take a quick 2-minute break and relax our muscles, unwind ourselves. Okay. Is Daddy here already? Looks like.
Yeah. What time is it?
We still have time. It's only 5:30.
5:50.
5:30.
Okay.
So we still have at least 25 minutes before we can disperse. Alright. So Arna, let me know once you're back. Yeah.
I'm back.
Okay, alright. So the next thing that we are going to look at is called compound probability. Meaning when there are 2 events happening together. So far, let's take another example. If I'm throwing a dice, I can get 1 to 6. Okay? If I'm throwing 2 dice together, okay, both have 1 to 6 written in it. Okay? What is the probability of getting a 7 when I'm throwing 2 dice? I have 2 dice. Okay? What is the probability of getting a 7 by throwing 2 dice? Meaning the sum of the numbers being 7. How will you solve that kind of a problem?
be 0%. Because there is no 7 in the cube.
No, so I said I'm throwing two dice together, and some of the numbers coming there as 7.
2 out of 6.
That is one possibility. 2 and 5 also could make it 7. 2 and 5 can also make it 7. 3 and 4 can also make it to 7.
1 and 6. No.
1 and 6, 2 and 5, 3 and 4. These are the three combinations that make it 7, right? And then you have to also look at when I'm getting 1 in the first dice, I can get a 6. When I get a 2 in the first dice, I'm getting a 5. That makes it 7. When I'm getting a 3 in the first dice, I'm getting a 4 in the other side, other dice. Now flip that. I'm getting a 4 in the first dice, I'm getting a 3 there. I'm getting a 5 in the first dice, I'm getting a 2 there. So basically we are talking about total 6 scenarios like this. Let's look at this chart. Okay, this is the value of the first dice. Okay, 1, 2, 3, 4, 5 and 6. Okay, here on the second dice I'm putting the numbers here, 1, 2, 3, 4, 5 and 6. Okay, I'm getting a, here I'm getting 1 in both. Okay, here I'm getting 1 and 2. So I'll show you guys, okay? Let me draw it and then I can show it to you guys also on the screen. I'm getting 1 and 3, 1, 4, 1, 5, 1, 6. Now look at this one. You are getting a 2 and a 1. So this is vertical one is 1 dice, horizontal is another dice, okay? I'm just looking at the combination, what I'm getting, different combinations, okay? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Same way, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4. This might look very tiring to you guys. That is okay. But this gives you a clarity also when you do the things, okay? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So now you should look at this one, right? For every value on the first dice, there is a corresponding value on the second dice, right? So you are essentially looking at 6 into 6, 36 combinations that you can possibly get. Yeah? So when the first dice gets a value 1, you can get 1 or 2 or 3 or 4 or 5 or 6 on the second one. When the second dice gets a 2, you can likewise get a 1, 2, 3, 4, 5, 6 on the second one. When the third one gets a 3, you can possibly get 1 to 6 in the third one also. So this gives you 36 combinations. What are the questions? What is the possibility of getting a sum of 7? What is the probability of getting a 7 by throwing 2 dice? Now let's look at where it's getting you 7.
I think it's diagonally.
This one?
It's diagonally.
Yes. I'm going in a simple way, and then I'll see. Then we can relate. If you look at this, these are the 6 combinations where your value is 7. Yeah. So 6 out of 36 is the probability of getting a 7. Getting a sum as 7 when you are throwing 2 dice. Okay? Now, what is the takeaway here? When we are throwing 2 dice, when you throw 1 dice, okay, what is the possibility of getting one number? It is 1 by 6. Okay? Our total possibility is total options that you can get is 6. When we are throwing 2 dice, what are the different options you will get? That will be 6 into 6. It actually gets multiplied. Okay? If you are throwing 3 dice, every dice gives you 6 options. 6, 6, 6. The total number of combinations that you're talking about is 6 into 6 into 6. Yeah? Are you guys with me?
Yeah.
Arna, see what's up? Now, so here in this case, what we had to do was, what is my total number of options? Every dice gives me 6 options. I'm throwing 2 dice together. So that gives me 6 into 6, 36 options. Now you have to look at how many ways you can get a 7. So you could have counted, okay, if I'm looking at the first one, if I have a first one as 1, second one as 6, that is one option. If I have 2 as the first one, second one is 5. 3 as the first one, 4 is the second one. And if I reverse it, my first one gets a 4, second one gets a 3. My first one gets a 5, second one gets 2. First one gets 6, second one gets 1. So there are 6 combinations. So total options are 36 and possible options are 6. So 6 by 36, that is how you will do it. Now let's look at one more sum, okay? With a similar concept. Now, let's say I have one coin, okay? I have one coin. Okay? When I toss the coin, what can I get? Head or tail? I have 2 options. If I have 2 coins, how many total options I can get? 2 into 2. Because every coin gives you 2 options. Since you have 2 coins, you will get 2 into 2 options. Meaning, you will get a 4 option, meaning 4 combinations. You can get a head and a tail, head and a head, head and a tail and a head, tail and a tail. Yeah? So this you can just look at with one thing being thrown. Yeah, no? Yeah. 50-50, yes, it is 50-50, but what I'm trying to say here is that when, let's say, you are dealing with when you were dealing with one dice, right, you had 6 options, 1 to 6, right? If you are dealing with 2 dice, how many options you get? 6 options for the first one, 6 options for the second one. So 6 times 6, 36 options is what you will have. When we put the table, right, you saw, we got 6 into 6, 6 times 6, 36 options. So if you have 3 dice that you throw, you will get 6 into 6 into 6, that many options. And if the question asked is, okay, if I am throwing 3 dice, what is the possibility of getting a 9? Then you have to look at, okay, how many total values I can get? 6 into 6 into 6. Now, how many ways I can get a 9? I can get a 3, 3, 3, that is one option. I can get 3, 6, 3, that is second option. 6, 3, 3, third option. And you have to evaluate all the possible options. 5, 2, 2, another option. 4, 3, 2, another option. So then you count those options, and that makes options divided by 6 into 6 into 6. That gives you a total value. Total probability. So this is what is called compound probability. Okay, so now let me try relating that with a coin scenario. Let's say if you have a coin. One coin, you are tossing one coin. What you can get? You can get a head or a tail. Very simple, right? Now if I have 2 coins that I am tossing, what I can get? I can get a head in the first one, tail in the second one. That is my first option. What I can get? I can get a tail in the first one, head in the second one. Yeah? What I can get? I can get a head and a head in first and second one. What I can get? Other option, tail and tail in both the options. So I'm getting 4 options. How it comes is, first one gives you 2 options, second one also gives you 2 options. You multiply both of them. That is the total number of options you will have. That is what you see here. If you have 3 coins, you don't have to do this way. How many options you will get? You can simply use, okay, first coin gives you 2 options, second coin gives you 2 options, third coin gives you 2 options. Multiply them. That's it. Yeah?
Mm-hmm.
So you have 2 into 2 into 2, that is 8 options. That is the total number of options you will have. And based on the question asked, let's say somebody says, okay, if I am tossing 3 coins together, what is the possibility of getting 2 heads? So then you'll have to say, okay, fine, if I'm getting a head in the first one, I can get head in the second one or in the third one. So I get total, with first one being head, I can get 2 options there. If first one is tail, what is the possibility? I have to get both options in this one. So that makes it, so you have to think about it, okay? So you have 3 coins, right? So first coin is head. It could be tail. If this is tail, this could be head. There are 2 options, okay? Now, if you have a head, okay, this is not the way to look at it. Okay, let me put a clearer picture. So let's say if I have 3 coins, right? What all I can get? I can get a head, tail, tail. I can get head, head, head. Okay? 3 coins. I'm tossing 3 coins together. Okay? I can get a head, tail, head. So first one is, okay, if I have a head, I can get a head and tail. So there are 4 options. Now if I have a tail, tail, I can get a tail, head, head. I can get a tail, head. I can get a tail, head and tail. So I just looked at the values here, okay? Meaning if I'm tossing 3 coins, what are the possible values I can get? I know that, okay, if I'm tossing 3 coins, I can get 2 into 2 into 2. What we're trying to find, the question was, how many times you can find 2 heads? That is why I have to plot this one. What are the options when I can get 2 heads? This is not there. This is not the one, okay? So I can get 2 heads by having first and third as head. I can get 2 heads as first and second being head. I can get 2 heads as second and third being head. That's it. So I know that there are 3 options. So 3 out of 8. Total options are 8. Getting 2 heads is 3.
Mm-hmm. Yeah.
So you did not have to do this much. You could have thought, okay, I can get first and second head. I can get first and third head. I can get second and third head. That's it. There is no 4th option. Right? So that is how you can derive this and calculate. Okay. So first thing you have to remember is how many possible options I'm looking at. What is my first coin giving me the option? Let's say coin, beat, dice, whatever it is, right? What is that this one is giving? What is the second one is giving? You have to multiply them. That gives you the total number of options. And then you have to find out the unique ones that has been asked. Okay?
Mm-hmm.
Am I making it complicated?
No.
Were you able to follow that, Srivatsar?
Yeah.
Okay. Arna, was it
What?
understandable?
Yeah.
Okay. So I see this might not be easy to go in one go. Okay. It's possible. Okay. Not every concept we understand in one go. What I would suggest is watch the video of the class one more time. Okay, because I'm going to give you guys homework tomorrow, right? So I would suggest you guys watch the video of the class one more time after the class, tomorrow or day after, and then only try attempting the assignments. Okay? If there is something that you did not understand well, you can always refer to it and make sure that your understanding is correct before you try attempting this assignment. Okay? And if you get stuck somewhere, don't worry about it. It's just a matter of figuring out what you have understood and what you have not. And we will, if there's something that is still complicated, I can explain it further. That's okay. Alright? That brings us to the end of the class.